In this video, we're going to be talking about calculating molarity. Now, before we talk about calculating molarity, let's go ahead and discuss a common term that we've probably used in our everyday lives, and that term is concentration. Concentration is defined as the amount of solute in a given amount of solvent. An everyday example that you might be familiar with is making juice from concentrate. So maybe some of you guys at home have seen a container like this, and this would be like a concentrated container of orange juice. And there is lots of solute particles, so those would be like the orange pulp and things like that, and really not much solvent. And you wouldn't eat this or drink this just as it is. What you need to do is you need to add more solvent or add water. And what you would end up getting is you would get a less concentrated orange juice. Notice that when we are creating that orange juice, that the amount of solute is the same, but we have added more solvent. Now, the idea of using these terms concentrated and less concentrated are fine when we're talking about everyday examples, but as a chemist or as a scientist, we want to be able to say exactly how concentrated it is. We need an exact value. And one of the reasons why we need an exact value is because we want to be able to make any results that we have to be repeated by other people. So we need to be able to have an exact value. That exact value is called molarity. So when we need to figure out that exact value, we use this term. And molarity, which actually has a unit of a capital M, is defined as the number of moles of solute per 1 liter of solvent. If we were to write out a formula, what we say is molarity would be equal to the moles of solute. Notice that those units for moles are just MOL, and it would be divided by the volume of solvent. And that volume must be in liters, represented by L. If we wanted to rewrite this, we could rewrite this as a very simple equation that says M, that capital M again means molarity, equals moles divided by volume. Our units of molarity will always have the units of moles over L. You could either use the units of moles divided by L, or you can use the capital letter M. Either one you can use. So let's go ahead and see how this chemical or this equation can be used in an example. A solution of sodium bromide is made by adding 0.653 moles of sodium bromide to 2.35 liters of water. What is the concentration of the solution? Now, a couple things that I want to point out before we start identifying things. Our solute is sodium bromide, NaBr, and our solvent is water. Those will be important because we need to be able to say that it's moles of solute over solvent. So that's an important idea when we are plugging things into our equation. Now let's identify what's actually given in this equation so that we can be plugging things in. The first thing that we are given is that we are given the amount of moles, and we know that it is 0.653 moles of sodium bromide. We are also told that the volume is 2.35 liters. The unknown is molarity, our concentration. So we have our equation. This is the equation from the previous page. And the first thing that we want to do is we want to plug in our given value. So notice that I have replaced the moles of solute with the actual moles, 0.653 moles of sodium bromide divided by 2.35 liters. And if I divide those two values because they're on top of each other, that means division, I will get that my concentration is 0.277. I have the capital M for molarity, sodium bromide, or you could have MOL divided by L. So either one of those units would work. So a very simple equation and a very simple example where you're just doing a straight plug in and solve for your unknown. Example 2 is a little bit more complicated. It just has a couple extra steps. So let's go ahead and take a look at that one. A chemist needs to make a 5.10 liter of a 0.950 molar solution of K2CrO4, that is potassium chromate. How many moles of potassium chromate are needed? How many grams should the chemist measure out? So there's a couple different things. Again, our solute here is our potassium chromate. And notice that it really doesn't say anything about the solvent. If it doesn't say anything, assume that it's water. So water is considered what's called a universal solvent, and the vast majority of the time when we are dissolving something in solution, we're dissolving it in water. So almost always our solvent is going to be water. Now let's identify what our givens are. We are given the volume of the solution, and the volume is 5.10 liters. We are also given the molarity, and we're given that the molarity is 0.950 molar. What we don't know is that we don't know the moles, and it also asks for the grams. So we need to be able to solve for these two things. Now we have this equation, but what we want to do with this equation is we want to rearrange it and solve for moles. So in order to rearrange this and isolate moles, I'm going to multiply volume on each side and get this equation right here. So notice now I have volume of solvent times molarity is going to equal my moles of solute. Go ahead and plug in my values now that I have my equation solving for my unknown. And I get that I need 4.85 moles of potassium chromate. Now that solves the first part, but the second part has to do with grams. So let's go ahead and see how we can solve for grams using this new information. So you have the number of moles, but you also need to get the number of grams too. We need to go back and we need to remember that we can use molar mass as a conversion factor. Molar mass is a very, very helpful conversion factor, and it allows us to convert back and forth between moles and grams. The molar mass is 194.188 grams per mole. Now, I calculated that using my periodic table, and if you don't remember how to do that, make sure you guys go back and you watch the video where I talk about molar mass and how to calculate that value. Now, if I were to write this out, I would say that 1 mole of potassium chromate, if I wanted to weigh that out, it would weigh 194.188 grams. So now we have this conversion factor, and now we can convert our moles, which we got in the previous one, into grams. So setting up my equation, I'm going to take my 4.85 moles of potassium chromate, and I'm going to multiply it by 194.188 grams of potassium chromate divided by 1 mole of potassium chromate. Notice that I put my mole in the denominator because I want my moles to cancel out. So what ends up happening is I'm going to multiply my 4.85 moles multiplied by my 194.188 grams of potassium chromate. And what ends up happening is I get 942 grams of potassium chromate. Now, if you're wondering about that value, because if you plug this into your calculator, you might have gotten a slightly larger number, or excuse me, slightly longer number. Now, what I did is my 4.85 moles has 3 digits in it. And I'm going to go ahead and keep 3 digits in my answer. So that's why I have 942 grams of potassium chromate. So if this scientist wanted to make the solution in the previous page, he would need to weigh out 942 grams of potassium chromate and dissolve it in the amount of water that we had.